So this is Honors Algebra 2 Pre-Calc. We are still doing section 2.3, which is the Intro to Functions. So in this video, we're going to focus on two major things: function notation, and then finding the domain and range of a set of functions. So of each function in a bunch of examples. So let's start with function notation. If y is a function of s, meaning that either the inputs and outputs show us that it passes and doesn't have any repeats in x, or we have a graph and it passes the vertical line test, we can write y equals f of x. So that's an f parentheses x on the inside. And then, so what this is saying is a function of x, where x is the input. So for instance, y equals 2x plus 5 is a function. If you graphed it, you would see that this looks something like a line that looks like this, right? So it definitely passes the vertical line test, right? It's a big old line, all right? So we can write it as f of x, right, equals 2x plus 5. Now, it doesn't have to be f of x. It could be g of x or h of x or q of x. And what you're going to find as you move forward in math, when we have multiple functions in the same problem, you will have an f of x and also a g of x, or you might have an h of x or a j of x or something else, right? So it doesn't have to be f. Usually f is the go-to one that we use if we only have one function, because it's called a function, which also starts with the letter f. To evaluate a function for different x values, we plug in for x. So for example, f of 3, and that's how we read this, is f of 3, not f3, not 3 times f. That's not what this means. It means f of 3. F of 3 is 2 times 3, which would take the place of the x that was in here, right, either of those, plus 5, which is going to be an 11. So what that means is that the y value of this function at x equals 3 is an 11. So essentially it's the point 3 comma 11, if that makes it easier to picture. So we have 3 comma 11, right, where this was the x and this was my y equals f of x, right? And if I wanted f of negative 6, so that's how I'd read this, f of negative 6, I'd get 2 times negative 6 plus 5, which is a negative 12 plus 5, or a negative 7. So negative 7 is the y value when x is negative 6. So negative 6 comma negative 7 would be my x comma y, okay? So that's how we evaluate a function. Now, before we move forward, we're going to do a couple quick examples. This will be our E3 and P3 of evaluating functions. And I'm intentionally going to give you some that have just the one x and some that have multiple x's. So we'll see how that goes. So let's do our E3, okay, so in E3, we're going to evaluate the function, and we're going to do the same in P3, and I'm actually going to give you an f function and a g function, so we're going to say like E3 because I'm lazy. Okay, so let's say f of x is 3x minus 2, and let's say that g of x is x squared plus 4x minus 3. Okay, and then in P3, we'll do h of x equals negative 3x plus 1, and we'll do j of x, right? So it doesn't have to be an f. And we'll do an x squared plus 3x minus 5. Okay, cool. Just made up random functions. Okay, so now here's what we're going to evaluate, right? We're going to do f of 2. We're going to do f of negative 4. We're going to do g of 3, and we're going to do g of negative 2, okay? We'll walk through those together. And then on this side, with my h and my j, let's do h of, let's do 3, and let's do h of negative 1, and let's do g of 2, and g of negative 2. Sure. Oh, not g. Sorry, they're not g's. They're j's. My bad. My bad, team. My bad. All right. Cool. Okay. So, anywho, here we are. Okay, so let's walk through E3, and then you can try P3. All right. So f of 2 is going to mean take this f function, and anywhere I see an x, I plug in a 2. So that's a 3 times a 2 minus a 2, which is going to be 6 minus 2, or a 4. Now, if you're able to plug that in your head and jump to here, do I think you're cheating? No, congratulations. I think that you're able to do order of operations in your head, and that's fine, okay? F of negative 4 is going to be a 3 times a negative 4 minus a 2, which is a negative 12 minus 2, which is a negative 14. And again, If you're jumping from here to here, I don't think you're cheating. I just think, oh, hey, you're probably pretty good at math, which is how you landed in my class. It's fine. If you need this step because you feel like you're making simple math errors, I'm also not judging. That's fine, right? We, as people doing these problems, need to find the right balance of work that we personally need. And again, on something like this, if you're jumping right to the end, I don't think it's cheating. All right, g of 3. Now, g is a little tricky because g has two different x's. It has an x squared and it has a 4x. So I need to plug that 3 in both spots. So this is going to be a 3 quantity squared plus a 4 times, oh, sorry, it's squared and I wrote cubed, my bad, plus a 4 times a 3 minus a 3, right? So that's going to be a 9 plus a 12 minus a 3, right? Which is a 21 minus a 3, so I get an 18. And again, if you jump into it's okay, like if you're jumping straight to that, it's fine. Be careful because it's easier to make mistakes as things get a little bit more complicated. And then for my g of negative 2, again, this is where you have to be careful because we did talk about this with exponents. This is a negative 2 squared. That's going to come out to be a positive 4 plus 4 times a negative 2 minus a 3. So that's going to be a positive 4 minus an 8 minus a 3. Remember, with addition and subtraction, you work left to right. So 4 minus 8 is going to be a negative 4 minus 3, so I'm going to get a negative 7 as my answer, right? Okay, so you can pause me if you want. I'm going to go ahead and walk through P3. So h of 3 should be a negative 3 times a 3 plus a 1. So that's a negative 9 plus 1, which is a negative 8. H of negative 1 should be a negative 3 times a negative 1 plus 1. Well, I'm pretty sure that's 3 plus 1, so I get a 4. Now, for j, I have two x's, the same way I did before, right? So I'm going to have to be careful. I have this 2 quantity squared plus a 3 times a 2 minus a 5. Well, that's a 4 plus a 6 minus a 5. Since for addition and subtraction, they're on the same level, we work left to right. I'm going to get 10 minus 5, which is a 5. Right? And remember, we did discuss in that other video, there is another way to do that. Logically, you can also just combine the positive stuff together and say, oh, these guys are positive minus a 5, so that's 10 minus 5. And you could do the same thing here, right? If you had combined your negatives together, you would have gotten a 4 and then a negative 11. Well, sure enough, 4 minus 11 is a negative 7. When you plug the negative 2 in over here, make sure that that negative 2 is in parentheses when you square it. Now, if you don't want to show this step, you can just square it in your head and say, oh, hey, that's a positive 4, but you need to know it's a positive 4. Plus a 3 times that negative 2 minus a 5. Right, so I'm going to get 4 minus 6 minus 5. So that's a 4 minus an 11 yet again. So I'm going to get another negative 7, which was totally not my intention, but here we are. Or again, if you worked left to right, you would have gotten negative 2 minus 5, which is also a negative 7. So that's our E3 and P3, okay? So that's how we evaluate functions. Most of what you see moving forward in math is going to be functions. Not everything. Certainly we do entire sections of calculus where we deal with things that are not functions, but most of what we're going to see are functions moving forward. Okay, so now let's talk about domain and range. So in these next set of problems, what we're going to do is we're going to find the domain, which we usually, that's not how you spell that word. Come on, Hogan. Domain, which we usually abbreviate D, and range, which we usually abbreviate R, of each. And I'm going to say relation, knowing that some of them could be functions, right? Function is a more specific brand of a relation, right? Relation is a really generic term. So for example 4, we're going to walk through a couple different possibilities, and hopefully that gets, rather than write a whole bunch of rules that you're not going to love having to write down, I want to walk you through examples and kind of logic through how domain and range work. So, so in example 4, we're going to start with a table. Let's do 1, 3, 5, 2. And let's do, oh, and actually, let's say each relation, and then I'm going to ask you, is it a function? Because some relations are functions and some aren't, right? Okay. And let's do 0, 3, 6, negative 1, right? For B, we're going to do a graph. You can assume that points on my graph are at nice, happy whole numbers. Well, I should say integers, right? Meaning I don't mean for anything to be at like 1.2. I'm aiming for 1. I'm just terrible at graphing. So I'm going to put a dot here, and here, and here, here. Okay, great. All right, so, and then we're going to do a C. where we're going to do we're going to do an open circle right here, and we're going to go to a closed circle right here. So open circle to closed circle, and I'll explain to you what I mean by that. All right, cool. All right, so I gave you 3 very different examples, and we're going to walk through how to find the domain and range of each one of these and discuss whether or not they are functions. Okay, so for A, remember that domain is all of the x values, right? All the inputs, right? And range is all of the outputs, the y values. One way to think about that is that D comes before R alphabetically and X comes before Y, and input comes before output if you're going alphabetically. So when we have a list of values, which is what's happening both here and here, right? We have a list of x values. The way we're going to do this is we're going to say domain with a D and a colon, right? And we're going to put this, they're called braces, but I always call them squiggly brackets because I clearly failed at basic mathing. And then what we're going to do is we're going to list the x coordinate, so we're going to list the x's in ascending order, right? Ascending means getting bigger, right? So in ascending order, okay? And what we're going to do is we're going to skip any repeats. So if something happens twice, we're not going to say that it happens twice, okay? So if I list these in ascending order, the 1 would come first, but then the 2, because I intentionally put things out of order, so 2, and then 3, and then 5. And that's my list, okay? That's my domain. When I list my range, I'm going to do the same exact thing, right? So I'm going to list my y values in ascending order. Well, the smallest y value is a -1, followed by a 0, a 3, and a 6. And that's it, okay? So if we have a list, that's what it's going to look like, okay? Now, for B, I have a list here. It just doesn't look like I have a list, but essentially this picture is a list of 5 separate points, just like this table was a list of 4 separate points. This is the point 0, 2, right? This is the point 1, 3. This is the point 2, 1. This is the point 1, -1, and this is the point 4, 5, I think. 1, 2, 3, 4, 5. I don't know. You know, I made up the graph. Okay. So this is a table. It's just like it's the same information as a table. It's listing 5 points. So my domain is going to be those x coordinates in ascending order. Well, the easiest way to do x coordinates in ascending order is to read left to right because lower x's are to the left and higher x's are to the right. So the first x is 0. And then there's 1. But it is worth noting just for us that it happens twice. Oh, sorry. This one is a function. I forgot to answer my question. This is a function because there's no repeats in x, right? No repeats in x means it's a function. Okay, so the 1 happens twice, which is worth noting right away that what that tells me is that it's not a function, right? I have a repeat in x, and also I would fail the vertical line test, right? Fails the vertical line test, I hit both of those points. The next x coordinate is 2, and then the last one is 4. Notice that even though I had 5 points, I only have 4 x's because one of them was a repeat. And the range is just going to be all the y values. Well, again, if you want to find the y values easily, start at the bottom to get the lowest y and then read up. So the lowest point has a y value of -1. The next lowest point has a y value of 1, and then 2, and then 3, and then 5. Notice I have 5 y values because all of the points had a different y value. Okay, so again, that's kind of a list. So what I want to point out is that neither of these is a particularly realistic thing that you're going to be asked to do moving forward in mathematics. Because it's really rare that we're just given a table of values or that we're given a picture that's a whole bunch of separate dots. Now you might see that in some statistic stuff because that's what a scatter plot is and that's how we collect data sometimes. So you could see the domain as the inputs of a data set, right? Where maybe the input is I don't know, height and the output is weight, right? Like height versus weight chart or something. Or you could see it where maybe the input is hours of studying and the output is an SAT score. Like you could see this as a series of points. But realistically, moving forward in what we're going to do in calculus, you're not going to see very many of those. So knowing that that's not going to happen very much, what we're going to see far more often is graphs. Now, not this particular weird, funky graph that I'm giving you because I obviously drew a line segment that has an open end and a closed end. It is only a segment, and that's not a typical graph. When we get to example 5, we'll do some more typical graphs. But I wanted to use this as a good way to show you how we can use what we learned about parenthetical notation from chapter 1 to show how we can find domain and range. So here's the problem. Both of these are lists. That's what these braces are, right? The squiggly brackets that are called braces, those are lists. It's a list of numbers, right? But this isn't a list. because there are infinite x values in here, right? We get very close to this open circle but don't actually reach it, and then every x value on this line segment. So 0.00001, 0.001, 0.002, 0.0 or 0.7, all of the x's, infinite x's along this line are part of the domain. So when we write this domain, the easiest way to do it is one of two options. Let me give myself a little more space. So I prefer, so this is Hogan's fave. I prefer parenthetical notation, but also okay. I'm going to show you inequality notation. So also okay, just because it's not my fave doesn't mean there's anything wrong with it. The way I would write this is that the first x value is 0, right? Because x's are left to right. So the first x is 0, the last x is at 4. So I'm going to write that this is from 0 with a parenthesis because of the open circle to 4 with a bracket. The other way to write this is 0 is less than x is less than or equal to 4. What this is saying essentially is that this graph only exists. So these are the same thing. These are both the domains, right? This graph only exists for x values between 0, right? So like this is the start of this graph, and this is the end of this graph. And that's it. There's nothing after 0 and 4, right? If we do the same thing with the y, right? If I look at this graph and I think, okay, well, there's nothing below 0. This graph seems to start at y equals 0 and go up to where y is 2. So what's going to happen is my parenthetical notation would be that the starting y value, the lowest this graph gets, is 0, and it goes up to 2. Notice that the 0 has a closed dot, so the graph actually hits 0, and then it goes up to 2. The other way to write that is 0 is less than or equal to y is less than 2. Notice that for range, it's not x, it's y. So one of the many reasons I prefer this is because it cuts out a possible error that's really simple but would matter. Most of us would accidentally put an x here. We don't mean to, but we're not thinking about it, and x is sort of the default variable that we use for everything. So it's not an x, it's the y's, right? This is the y values for the range, but a lot of us do that wrong. By just writing this, I make my life a lot easier. I don't care which one you pick, I'm just saying that's the reason, that's one of many reasons I prefer it. The other reason I prefer it is it's just a lot more succinct. The less I have to write, the better. All right, so we're going to do a P4 that's similar, right? I'm going to give you a table, I'm going to give you a bunch of points, and I'm going to give you a graph. And then we'll go ahead and start doing some graphs that are a little more realistic to stuff that we're actually going to see. So for P4, oh, I'm sorry, and I didn't mention that that one was a function. For C, right, so sorry, E4C is a function. It passed the vertical line test. If you look at this graph, right, passes the vertical line test. My bad for forgetting. Sorry. So E4C was a function. My bad for forgetting. Okay. So P4, let's do a table. And then for B, let's do one of those ridiculous graphs again. Again, assume that my intention is for dots to be on nice, happy integer values. And then for C, let's do okay, cool. So again, assume that I'm aiming for nice, happy integer values. Okay, so find the domain and range of each and tell me if it's a function. So I'm going to go ahead and start. So for this one, right away, I see the 2 repeats in x, and I say, okay, this one's not a function, right? A is not a function. When I list the domain, I list the x's in ascending order, so -3, -1, and 2. I don't list the 2 twice. For the range, I'm going to list the y's in ascending order, so 4, 5, 6, 8. And that's it, right? Not a function. For B, I look at this graph and I can see visually that it passes the vertical line test because none of these fall on the same vertical line, right? So this one is a function, right? It's helpful to list the point values. This is -1, 0. This is 0, 1. This is 1, 4. This is 2, 5. And this is 3, 0, right? So when I go ahead and do my domain, the easiest way to get the x's in ascending order is to start left to right. So -1, 0, 1, 2, 3. My range, if I start at the bottom and work my way up, is 0, which does happen twice, but I only write it once. 1, 4, and 5. Okay, so that one is a function. When we look at C, C is also a function, right? You can see from the vertical line test, I'm all good. It is a function, right? I look at this x value. I see that the x starts at -1 and ends at 3, right? So my domain is going to be including -1 up to 3, which is not included. If you don't like parenthetical, I'm going to say this is better. The other way to write this, though, would be -1 is less than or equal to x is less than 3, right? My range is the lowest that this graph gets seems to be a 2, and the highest that it gets seems to be a 3, right? So my range is going to go from 2, which is a closed dot, so it's included, to 3, which is open. Or the other way I can write it is that y is less than or equal to, sorry, backwards. 2 is less than or equal to y is less than 3. Sorry, sometimes my brain just checks out and I have a bad moment. All right, cool. So now we're going to go ahead and do E5 and P5, which are going to be better depictions of stuff that you might actually see. So we're going to learn a whole bunch of functions, right? We're going to learn a whole bunch of functions moving forward, but I'm just going to put up a couple so that we can see what they look like. So some of the common functions that we're going to learn are lines, right? So let's do E5. I want domain and range, so I'm just going to say D and R, okay? So for A, this is the line y equals 2x plus 1. For B, this is y equals x minus 1 quantity squared. For C, this is y equals the square root of x minus a 2. Okay, so we're going to find the domain and range of each, okay? So remember, domain and range are essentially what's the first x value, what's the last x value, right? What's the first y value, what's the last y value. So when I do domain, right, I'm going to read from left to right and see where the first y value is. Well, because this arrow goes left forever, right, this arrow also goes down forever, but it goes left forever. That means that my starting x value is a negative infinity. And because this arrow is going to go right forever, right, it's going to go up and right forever, but so it's going to go to infinity. So this is left forever, right? That's what infinity for the x, negative infinity for the x's means left forever, positive infinity for x's means right forever, and this graph is doing both of those because of the arrows. The other way to write this, so there's two other ways to write this. You could write x is an element of reals, which means any real number, or you could write all real numbers. That's not how you spell numbers. Come on. It's not like I'm a math teacher. This is my favorite of the three, but x is an element of reals would be my second favorite. All real numbers is my least favorite because, come on, man, why do I want to write more, not less? For my range, right, notice that for range, I'm going down to up, right, because I want the negative, the lowest value first. Well, this goes down forever, so that's in a negative infinity because this goes down forever, right? And then this one goes up forever. So again, I get all real numbers. Now, there are other ways to write that. You could write it as y is an element of reals. Notice it's a y because it's the range. Or you could write it as all real numbers. Again, I'm going to fall back on the fact that the laziest, easiest thing to do is write negative infinity to infinity. All right, let's talk about B. So B is y equals x minus 1 quantity squared. So if we go from left to right, right, and down to up to find my range, right, okay? So left to right, use your hand. I start going from the left to the right. What I notice is, oh, hey, this goes left forever, right? This goes left and up forever, right? And this one goes right and up forever. Okay, so what I notice is this goes left forever, and so I'm gonna have a curve forever this way, which means I start at negative infinity. And then I have a curve, I have a curve, I have a curve. Oh, look, it's gonna go forever to the right also, so I go to infinity. Again, you could write it in either of these two ways instead. From down to up, I have no curve down here. No curve, no curve, no curve, no curve. Oh, I have a curve, and the curve starts at 0. So 0 is the first y value, but because these go up forever, it would be 0 to infinity. Remember, you're always putting a parenthesis after infinity. Again, just like you could have written this either of these two ways, the other way to write this one would be y is greater than or equal to 0, but make sure it's y because you're talking about range. Okay, so then for c, which is the square root of x minus a 2, right? Again, for my domain, I'm going to read from left to right. So over here, I have no graph, no graph, no graph, no graph, no graph. Ooh, graph! Starts at x is 0, and it has a closed dot. And then it's going to go forever left and up, right? That goes left and up. Or, sorry, right. Come on, guys. I failed kindergarten. Don't judge me. Right and up forever. Don't judge my failure of kindergarten. So this is going to be an infinity because it goes forever to the right. Okay? When I look at the range, I start down at the bottom and work my way up. No graph, no graph, no graph, no graph, no graph. Ooh, graph! Graph starts at -2 and goes up forever, right? And again, if you don't like that, the other way to write this is x is greater than or equal to 0. The other way to write this one is y is greater than or equal to -2, right? And either of those are fine, but I prefer the parenthetical notation. So I'm going to give you a P5 to try, and then we'll go from there. So again, you're going to find my domain and range. I'm going to give you some graphs. It's good times. All right. So P5. For A, I'm going to give you y equals x cubed. For B, I'm going to give you y equals 4 minus x squared. Close enough. And for C, I'm going to give you y equals the negative square root of x. Cool. All right. Oh, my bad. There's an error. Okay. Okay, cool. So you can pause me if you want, or you can go ahead and try it. It's up to you. Again, this is our P5, right? So here, right, I notice that this goes left and down, and this goes up and right. Everything's going forever, right? This goes up and right forever, this goes down and left forever. So what that tells me is all of these values are going to get hit from -infinity to infinity for both the x's and the y's, right? So there's my answer to the first one. For the second one, right, I see that this is left and down forever, and this is right and down forever. So down forever is definitely a thing. And left and right forever is definitely a thing. So my domain is going to go left forever, which would mean starting at -infinity, and right forever, which would mean ending at +infinity. But my range is going to start at -infinity, but notice it doesn't go up forever, it goes up to 4. So it's -infinity until 4. So again, if you wanted to write this one, you'd write y is less than or equal to 4, right? I think it's easier to use parenthetical notation, but hey, it's up to you. You do need to be able to read both, right? And again, for these, you could have written all real numbers, x is an element of reals, etc. For this one, right, remember that, now, so here, I notice that this goes right and down forever, right? So I know some things. I know right and down forever, but then I look at this endpoint at 0, 0, and I say, okay, cool, so that's the other piece of information I need. As I read from left to right, I realize that the first x value I hit is 0, and then I go on forever. So my domain is going to be 0 with bracket until infinity, right? Or the other way to write that is x is greater than or equal to 0. My range is going to go the opposite direction, because as I start at the bottom and work up from the lower y values to the higher y values, I realize that I hit this arrow first. So I must be starting at -infinity and ending at 0. So the way to write that is y is less than or equal to 0. Okay, so that's your domain and range. So just to chat a little bit, so we're going to talk about domain and range in a slightly different way than your book does for just a minute, because I think it's a valuable thing to do. So this is a bit of a preview ahead, right? So we're gonna put some notes that are a preview ahead. And what we're going to talk about is how, when you're looking at an equation, essentially there are only a handful of restrictions for domain. Okay, so we're going to talk about, so this is a bit of skipping ahead. and we're going to revisit this a lot later, but we're going to skip ahead a little bit. Your textbook doesn't address this right now. We're going to learn about the only 4 domain restrictions. Okay, and so I always call these the big 4. Now, you don't know enough to do a lot of them yet, but I'm going to show you what all of them are, and then as we come across them in the curriculum, because we will come across all of these over the course of this course in this class, when we come across them, I can say, hey, remember when we discussed the big 4 domain restrictions? Sorry, the computer fell asleep again. Okay, so the big 4 domain restrictions. So the domain of a function is all real numbers, meaning negative infinity to infinity, except, and then these are the 4 restrictions. Okay, number 1, you cannot divide by 0. Okay, so what that means is you say the denominator cannot be 0 and you solve for x. Okay, the second big restriction, only no negatives in even roots. Okay, so by even roots, I mean like a square root or a 4th root or a 20th root, right? Even numbered roots, okay? What you do to deal with that is you set the inside of the even root greater than or equal to 0 and solve for x. For 3, we have only positives inside logs. And what we mean by logs are logarithms, which you're not going to see for a couple more sections, right? So only positives inside logs. What we do for that is we set the inside of the log strictly greater than 0 and solve for x. And then the last one of these big 4, and again, right now this is going to be really over your head. A lot of this stuff is going to make 0 sense, and that's okay. But it's better to introduce you to stuff over time so that you can start to kind of sew all the information you learn into the fabric of this understanding and really flush out your knowledge. All right, so the 4th one is real-world constraints. What I mean by real-world constraints, so this is something that you only see really with word problems, okay? And I'm going to give you an example. So the example, so this is like a logic. For example, you can't have a negative, so a 0 or negative age. So like if your x in your problem was about someone's age, it wouldn't make sense for someone to be negative 20 years old, right? So that's a domain restriction. Okay, so I'm just going to put right over here, I'm going to put a quick little example. And again, so this is way past where we're at right now, okay? So this is way beyond where you're at. But if, for example, I gave you a function 1 over x minus 2, the domain of this function is going to be all real numbers except 2, because x minus 2 can't be 0, so x can't be 2. So the domain, we're going to write x is now in reals, x cannot be 2. Okay, oh, sorry, inching over so you can see that, okay? The other way to write that domain is to write from negative infinity to 2 and from 2 to infinity, which basically means skip over 2. If I gave you a function that looks like this, the square root of x minus 5, right? The inside of an even root can't be negative, so x minus 5 would be greater than or equal to 0, x would be greater than or equal to 5. So my domain would either be from 5 to infinity, or the other way to write this would be x is greater than or equal to 5, right? You don't know what a logarithm is yet, but suffice to say that it usually says log or natural log, which is ln. So let's say I gave you the log base 2 of, I don't know, x plus 8, right? The inside of the log has to be positive, so x plus 8 is greater than 0, x would have to be greater than a -8. So the domain of this thing would be either from parentheses -8 to infinity, or you could write it as x is greater than -8, right? And then I already gave you an example of a word problem, right? If x was my age and y was, let's say, my weight, the domain restriction on this is that I would have to start at 0 and go to, let's say, a reasonable age. Like, let's say we were talking about people's ages and we decided that it was not reasonable for someone to live to, like, I don't know, I don't think anybody's lived to 120, right? Just as an example, right? And that might, you could say x is greater than 0, but let's be reasonable. It probably isn't likely that my age is going to go past 120, right? So something like that. Again, this is way ahead of where we're at, but eventually you're going to be able to look at something and spot its domain and range and where it has problems, etc. So we saw some basic examples of that in like E5 and P5, but that's kind of the gist. So that is 2.3.